Okay, this is lesson 10.3a. And in this lesson, we are going to be generating equivalent expressions. In this part, we're going to be using properties to generate equivalent expressions. Okay, now first we have to know what the properties are, and then we will see that we can get equivalent expressions by using those properties. And equivalent means the two expressions have the same value. Okay, so let's talk about the properties. The first property is the commutative property. C-O-M-M-U-T-A-T-I-V-E. You pronounce that commutative. The commutative property says that when you are adding or multiplying, okay, this only works when you are adding or multiplying. Okay, when you are adding or multiplying, you can move the numbers around. Okay, I think about commuting in a car and moving in a car. Those mean the same thing, right? Commutative, moving. You commute in a car, you move in a car. Okay, so that's how I remember what that means. Well, let's talk about what it looks like with an expression. And we're going to use numeric expressions to show these properties. And then at the end, we're going to use algebraic expressions with variables. Okay, so let's look at addition. And we're going to look at an addition expression. For example, 3 plus 9. The commutative property says I can move those around. I can do 9 plus 3. And those will be equivalent expressions, meaning they have the same value. They're not the exact same expression because they're, moved around, but they have the same value, so they are equivalent. For example, 3 plus 9 is 12, and 9 plus 3 is 12. So 3 plus 9 as an expression is equivalent to 9 plus 3 as an expression because they have the same value. You can also do that with multiplication. You can do, for example, 8 times 2, and you can move those around and do 2 times 8, and they are equivalent expressions. Those two expressions, 8 times 2 and 2 times 8, have the same value. So 8 times 2 is 16, and 2 times 8 is also 16, equivalent expressions. They are worth the same value. So this might seem like, well, you already know this, you've been knowing this for a while, or maybe not, maybe you're just learning it, and it seems simple. But when we start putting variables in there, letters, this is going to help you remember that you can move a couple things around only with addition and multiplication, though. Okay, so let's go to the next property. It's similar, but it's not exactly the same. It's called the associative property. Okay, A-S-S-O-C-A-T-I-V-E. Associative. That's how you say that. The associative property says that, again, when adding or multiplying, only when adding or multiplying, only when adding or multiplying, you can change the groups. Now, what does that mean? All right, so let's give an addition example first. You might have 3 plus, and then do a grouping, and inside your grouping have 9 plus 2. The order of operation says you do the grouping first, right? But it's all addition. If you look at it, there's addition and addition. You're adding the whole time. The associative property says we can change the group and we will get an equivalent expression, meaning an expression that has the same value. So I could do 3 plus 9 plus 2, and those two expressions will be equivalent. Basically, what that means is if it's all addition, you can add in any order you want. That's what that means. So in this one, I add these two first because they're grouped. 9 plus 2 is 11. Then I add that 3, 3 plus 11 is 14. Okay. In this one, I add these two first because they're grouped. 3 plus 9 is 12. 12 plus 2 is also 14. So the expressions are equivalent. Okay. Now, that's basically the commutative property and the associative property basically tell you that when you are adding, you can add the numbers in any order you want. You don't have to go from right to left if it's all addition. Okay? You can add in any order you want. The same is true for multiplication. If you had, for example, 4 times 3 times 2, you could move that grouping around. This grouping says you multiply these first and then multiply by the 4 because of the grouping. Remember, with order of operations, groupings come first. But you could move the groupings around and you could do 4 times 3 and then multiply that times 2. But the associative property says if it's all multiplication, those are equivalent expressions and they will give you the same value. So let's test that out. This is 3 times 2, which is 6. And then I multiply the 6 times 4. 6 times 4 is 24. Okay. These two multiplied together, 4 times 3 is 12. If I multiply that times 2, 12 times 2 is also 24. So you see with addition and multiplication, as long as it's all multiplication, you can multiply in any order you want. That is what the commutative property and the associative property tell you. You can move the numbers around, you can group them in any way you want, multiply whatever you want first, as long as it's all multiplication, okay? And you will still get the same value. All right, we have talked about the distributive property before. So let's review what that means, okay? Distributive. We worked with the distributive property when we were doing GCF. We were taking an addition problem and changing it into a multiplication problem by taking the GCF of the two numbers and then multiplying that GCF times a new sum with the other two factors. Well, let's go over that again, okay? The distributive property basically says that I can take a multiplication problem like 4 times 2 plus 1. And I can distribute that 4 and an equivalent expression, meaning it will be worth the same value, would be 4 times 2, right? Like this, plus 4 times 1. That's what the distributive property tells me. That if I have a multiplication problem, I can distribute the 4 to the numbers inside the parentheses and I will get the same value. So let's test it out. In this one, I would have to do the grouping first. 2 plus 1 is 3, and I would multiply that 3 times 4. 4 times 3 is 12. Let's see if it works over here. There is no grouping over here. I just am going to do the multiplication first because order of operations says multiplication comes before addition. So this is 4 times 2 is 8. 4 times 1 is 4, and then I add those. 8 plus 4 is also 12. Okay, you see that this one is a multiplication problem, and this one is an addition problem. But the distributive property says those two ways of writing will give you the same value. So I can distribute the 4 to the 2, 4 times 2, and then the 4 to the 1, 4 times 1, and I will get the same value. Now, this is going to matter a lot when we have algebraic expressions and we have variables in there instead of numbers. Okay, let's do one more property. It's called the identity property. Okay, the identity property says that when you add 0 to any value, it does not change the value. So you know this already. 9 plus 0 is 9. Any value, 5 plus 0 is 5. So if we have x plus 0, you're going to get x. Okay? Any number, any value. We don't know what x is, but if whatever it is, if you add 0 to it, you're still going to have x. Okay? This matters when we start using variables. And the identity property also says when you multiply any number by 1, it does not change the value of that number. And you know that also. You know that 6 times 1 equals 6. You know that 9 times 1 equals 9. Well, here's the thing. X times 1 also equals x. So when you see the letter x, this is x times 1. If you see a letter that has no number in front of it, there's actually a 1 there. Okay, because x times 1 is x. All right, so that's 1x right there. All right, so keep in mind, when you see just x alone, that's 1x. Okay, there's no coefficient, but it actually does have a coefficient. The coefficient is 1, but you don't need to write it because 1 times x is just x. Okay, all right, let's talk about this now to see if these, let's see if these expressions are equivalent. Now, as soon as I see a grouping with a number right in front of the parentheses, I know I'm going to use distributive property because that says 3 times some number inside here. And I can't actually do the subtraction because I don't know what x is. So the question is 3 times x minus 2 equivalent to 3x minus 6? Well, let's find out. We're going to distribute the 3 to the x and we get 3x. Distribute the 3 to the 2 and we get 3 times negative 2, which is negative 6. 3x minus 6, 3x minus 6. So the answer is yes, they are equivalent. Okay, now let's look at this one. This says 2 plus x. This one says 1/2 times 4 plus x. So we're going to have to do some multiplication with a fraction to figure out if those two expressions are equivalent. So let's do that. We're going to leave this one aside for a minute because this is the one we're going to need to distribute. 1/2 times 4. That's the first thing we have to do. I'm going to do that up here. 1/2 times 4. Remember, to multiply fractions, I need a numerator and a denominator. So I give the 4 denominator. Then I just multiply across. 1 times 4 is 4. 2 times 1 is 2. Then 4 divided by 2 is 2. So this first distribution, 1/2 times 4 is 2. Okay? Now I'm going to add 1/2 times x. Well, how do I do that? Let's do it up here. 1/2 times x. Same thing, I need to give that x a denominator. Remember, that stands for a number. I just don't know what the number is. But I can still treat it like a number. 1 times x, remember, 1 times any number is that number. So 1 times x is x. 2 times 1 is 2. So what I get here is x divided by 2. Now, is 2 plus x the same as 2 plus x divided by 2? Are those the same? No, they are not. So no, they are not equivalent. So I would say 2 plus x is not equal to 2 plus x over 2. They're not equivalent. So if you put an equal sign and then put a slash in it, that means not equal. Okay? So in this lesson, you are using the properties of operations, the commutative property, the associative property, and the distributive property to write equivalent expressions and to see if two given expressions are equivalent. All right, this is lesson 10.3a, generating equivalent expressions using properties.